Welcome. This lesson will be very similar to the last lesson, except this time we're going to learn about compounded continuously. The formula is a little bit different, but again, this explains it very, very well. First thing I'm going to do is I notice I'm looking for my final amount, so my A is unknown. It gives me my principal. Wanda puts $800, so I'm going to take $800 and I'm going to times that by, now this is where this number E comes in. This is the number E. E is not a variable. E is the base of a natural logarithm, and it's 2.71828 and so forth. It actually keeps going. So when I put an E here, I'm actually putting a number, not a variable. It's E times, now our interest rate is 9%. And again, make sure you do your interest rate as a decimal. So I'm going to put 0.09 because it's 9%, and I'm going to times that by the number of years I put it in for, which is 7. So make sure you do the 0.09 times 7 first, and then raise e to that power, and then times it by 800. So what I did is I multiplied the 0.09 times the 7 first and got 0.63. Now, E on your calculator usually is the second function of your natural log, the ln button. So if you find your ln button, if you look above it, you most likely will see E with a little x above it. So I took E and I raised it to 0.63 and got 1.8776 ... And then I times that by 800 and I get a final amount of $1,502.09 if I round to the nearest cent. It says round to the nearest cent. But remember, E is a number, and it is on most scientific calculators. I would hate to have you type in 2.71828 repetitively. I would hope you find the E button on your calculator and use that. So again, don't overcomplicate these problems. Just plug in your principal amount, your starting amount, 500, take the number E and raise it to the interest rate written as a decimal, 0.1 times the number of years. Luckily, they just did it in 1 year. So 1 times 0.1 is 0.1. E raised to the 0.1 is 1.105 something, something, something. So try to use the long decimal in your calculator, times that by 500, and you find out he will have a total of $552.59. Well, let me jump ahead to make sure we get some, because I'll bet you anything we're going to have some that works backwards. So basically, I just took E, raised it to 0.11, got 1.111 times some principal amount equals 600, divide over the 1.11627, and I find out he would have had to have deposited $537.50 in order to have 600 at the end of 1 year. So in this one, we need to find the amount of interest he earned in a certain amount of time. So you ought to read the problem carefully. He ended up with $7,000. We don't know what he started with. It just says he won some money. He kept it in a savings account for 5 years, 5 years ago, and he made 2% interest. That's 0.02. So I took E raised to the 0.02 times 5. What's 0.02 times 5 is 0.1. E to the 0.1 is 1.10517 something something. So when I divide that over, I find my principal amount. The principal he started with, or what he won, was $6,333.86, but it didn't ask for the principal. It asked for how much interest he had earned in that time. So we take what he ended up with, the $7,000, minus off what he started with, the $6,333.86, and we find out he had a interest or earned interest of $666.14. So just be careful to read the problems carefully, and you should do fine on this lesson. Let's do one more, because this one had asked for the interest rate. What was the interest rate? So again, they started with $8,000 in their bank account. They ended up with $9,085 in their savings account, and they saved for a total of 1 year. So that's why we have a 1 here. We got to find out R, the interest rate. What's nice is I divide the 8,000 over. I get 1.135625 equals e to the r, because r times 1 is just r. Now what's nice is I take the natural log. The natural log just cancels this e to the r, leaving just r. The natural log of e to the r is just r. Then I take the natural log of the 1.135625, so natural log of both sides, I get 0.12718. Now it wants it as an interest, so what I want to do is I want to make sure I change that to 12.7 because we make it a percentage where we move the decimal twice, and it says round to the nearest tenth. Again, hopefully this one's fairly simple after the last lesson. If you have any questions, please do bring them to class.